good morning. To start this event today, I hope we have a good mood and for this class will run smoothly. I will introduce our lecturer today. First, we have Dr. Pooja as Professor Department of Computer Science from Vidyavardhaka College of Engineering with the topic Bio-informatics. Yeah, before we start for this class today, I would love us to pray first according to your own religion and belief. So everyone, let's pray start together. Yeah, thank you. Pray finish. And next session we will.
Hello.
Dr. Pooja, the time is yours. Hello?
Ma'am, can I take over?
Yeah, you can start for this class today, Doctor.
Thank you, madam. Hope I would be able to take over the session. Kindly, could you confirm? Is the screen visible? Well, a very good morning to all of you. I hope the entire screen is visible. Madam, there seems to be some issue. It seems to be echoing. Could you please check out, or shall I leave the meeting and join? Hello, everyone. A very good morning to one and all. I would like to take up my session on machine learning and its application. So fine. So what's basically machine learning? So when we talk about machine learning, as the very name says, what you need to say is you start training your machine to start on its own. And machine learning has seemed to be one of the significant sub. Madam, do I disconnect and join again? Hello.
Yeah.
Madam, no, can I go ahead? Could you please confirm?
I can hear your voice clearly. Can you?
Okay, I will try to reach you. Hello. Hello.
Maybe you can join with one account only.
I mean, hope there is no echoing there.
Yeah.
Can I go ahead?
Yes.
Madam, can I go ahead?
Yeah. You go ahead.
Okay, fine. So as we see, machine learning is basically an application of AI. We should say it's out of the several things that can be covered under AI. Machine learning is one area which enforces intelligence to happen within the machines. And what we basically look into is the machines start to learn them on their own, and they try to work on their own with least or almost no human intervention. And that is what usually marks the significance of machine learning. And with machine learning, a lot of experience does count. So that is things which have happened in the past, and they set as input to the next few machine learning tasks. Okay. So how does machine learning really stand different from the normal computers? Now, with normal computations and the way the normal computers have been working around, so there's a lot of programs that are written wherein a lot of emphasis is written on the way the task is programmed. But here, you leave it to the entire program to keep tuning itself with respect to the data. And when we say it learns by experience, it is more and much of learning from the past or with respect to the data. And this is how it gets tuned as to how it has to keep on learning, how it has to train itself and start doing things for better. So coming to machine learning, one can broadly see three categories. One is supervised learning, the other one being unsupervised learning, and the other one basically being reinforcement learning. So as most of us are aware, when it comes to supervised learning, you have supervision in place there. So when the tasks are priorly determined, you have, say, for example, the statement of what classifications probably you want to put the data into, or what is the type of task that is going to be in place. All those things are well defined for you. So that is supervised learning. So throughout the process, you have the outcomes defined and everything takes place according to that. So, so the entire algorithm keeps tuning itself so as to place the data in the required categories. So this is just one example. So we can have a number of supervised learning tasks, be it classification, regression, and all those things. When it comes to unsupervised learning, basically, when we say unsupervised, there is nothing which keeps supervising or guiding the entire process. So with unsupervised learning, the data is fed to the algorithms as it is, and the algorithm does its best to see that the groupings does happen, groupings or segmentations, or what we call as segmenting or clustering or grouping keeps happening on its own. The drastic and the difference, the important striking difference that you have between supervised and unsupervised machine learning is there you have priorly defined outcomes in supervised learning that keeps guiding the algorithms. In supervised learning, it is much of an exploratory process. It starts studying in its own and how it has to guide through the entire process of segmentation. So yet another class of machine learning is what is called as reinforcement learning. Now with this type of machine learning, especially we have two outcomes. So you have one is being rewarding and the other one would be called as punishing for the task. So you have a particular goal to be achieved. Now in the process of achieving the goal or achieving the required task, it is quite possible that you could come across n number of hurdles. That is probably which probably deviate the entire training process. So in reinforcement learning, at every stage, what happens is as the learning keeps accomplished goal. That means every time you take a step towards the accomplished goal, you are rewarded. And every time, say for example, it is moving towards say for example, a wrong action, it would probably be punishing. So that's the basic different types of algorithms you have. So when it comes to advantages of machine learning, so the first important advantage of machine learning would be they are highly fast, accurate, and efficient. So unlike the general algorithms which we write, which of course are subjected to their slow working, subjected to n number of parameters, be it with respect to the huge amounts of data, or probably with the accuracy with which they end up, or probably the final efficiency, the retrieval efficiency, machine learning really stands out to be different. And with machine learning, as I earlier said when I tried to define the machine learning, it is more of a process which requires very less or almost no human intervention. So therefore, it is basically an automation. And that is why it is one of the chosen trends for all the applications which are automated today. And huge range of applications, real life applications, be it in the form of agriculture, and all its connections in the fishing case, is quite easier for you to apply machine learning, which really keeps studying the history and start predicting things for good in future. And obviously we don't have any human intervention as such. And the very one important striking characteristic of machine learning is it starts looking into data from a multi-dimensional perspective. So when you have a multi-dimensional perspective for the data, it is possible that the data that you have in hand can be visualized from n number of dimensions. And the algorithms which perform analytics on this data can also be done from n number of dimensions. So say, for example, you have the sales data in your hand. And this sales data can be modeled from n number of dimensions, be it with respect to time, or be it with respect to the type of product, or be it with respect to the type of sales that's happening over years. It is possible for you to perform the analytics on this data from several dimensions. So this was only for illustration. So machine learning algorithms have the capability to look into algorithms from n dimensions. So what's machine learning basically? It's automating automation. That's the important thing. And starting to make the computers think, learn for themselves, and even train for themselves. So that is basic about machine learning. And of course, what remains as bottleneck is writing the software. And here, more than everything, data plays an important role in machine learning. Because when we say machine learning, a lot of learning happens just because of the data. So the algorithms capabilities, in fact, rely completely on the data. So if we can put up in graphically what makes the difference between traditional programming and machine learning. So in the first one, you see that you in fact feed the data, you have the program, you have a set of instructions coded out for a particular task to be achieved. Finally, you come up with the outcome. Whereas in machine learning, what you do is you have your input data. You probably also try to define what the outcome is. You keep specifying what is expected. And then now starts the role of the computer to start training itself, learning itself, and then it comes out with the best program on its own. And that is what we call as the machine learning model. So ultimately, rather than looking at the output in a machine learning process, we're looking to the machine learning model that has resulted from the entire process of training. So that is one thing which makes machine learning significant. So coming up with a machine learning model, which can probably come up with different outcomes. So what is great about machine learning, and how do we see that machine learning has been able to work out just like magic? So what stands as important entities in the entire machine learning process is the algorithms. The algorithms, in fact, act as the seeds that you're going to sow. And richer the data model will really be self-tuned so as to achieve desirable outcomes. And of course, who is the gardener here? It is you who is going to tune things accordingly, probably provide ingredients to the entire process as per the requirements. You start fine-tuning the parameters, or you start deciding what is the training and the testing phase in the machine learning. And the programs that we talk about basically become the plants here. So this is an equivalence as to how you can get good benefits when you start sowing good data and So what is ML in a nutshell? Huge collection which are trained, which can keep training themselves again and again to come out with a better outcome. And of course, every now and then you have a new algorithm coming in place, and almost every year we see to that there are hundreds of algorithms coming, machine learning algorithms, which keep getting added to the huge corpus of machine learning algorithms that are already existing. So, but any machine learning algorithm you take would usually be looking into three important things. So one is basically with respect to representation. The other one is with respect to evaluation, and the other one is optimization. So these three important tasks define how a machine learning algorithm would be optimal. So let's talk about representation. So when you're talking about the data being fed to the algorithms so as to come up with good machine learning algorithms. The next thing that comes in place is how I'm going to represent the data. So there are a huge number of ways in which probably the data could be represented. So say for example, and of course this decides how the respective algorithm is going to come up also. So say for example, when your entire machine learning process is actually tuned around a lot of decisions to be made at n number of stages, probably you can have the adoption of the decision trees. Or when you have too much of compounded logics that are present, which probably define in the form of association rules. Say for example, the huge application that you have for machine learning, which is basically the market basket analysis. Now there comes an important concept of what are called as association rule mining. So that is when you have a set of items in one place, how or and to what extent do they dictate the existence of other items? Or what is the extent to which this finds its utmost significance, especially in the sales industry. So that is, you start defining the rules and your programs dictate how these particular rules have to be coded out in the logic. And then, of course, you have the individual data which can be represented as instances. When you can apply n number of algorithms, it could be the k-nearest neighbor algorithm, it could be the name-based classification algorithms which you have. These always try to pick instances of the several instances which will really matter and make a lot of progress for your algorithms to come out with good outcomes. And of course, you have Bayes and Markov net models, which are probably looking into more of statistical analysis, where you have these things, especially being adapted for supply chain management. And then, of course, comes your neural networks. So with neural networks, it is, as most of us know, everything is modeled in of a collection of neurons is made sure that it is tuned at its best. So though we will not dwell much into the neural network, a neural network is still a stream of machine learning which sees to that you have the best outcome. In fact, all the outcomes that with neural network are in fact treated as black box outcomes. Though you don't have much intervention to be doing with neural networks apart from setting few of the preliminary parameters, be it with respect to the bias, variance and all. But there is a lot of scope for us to get good outcomes with sufficient amount of accuracy in neural networks. Then comes your support vector machines, which tries to draw in spite of the non-linearity that you hypermargins, hyperplanes rather, which will really separate out the data in spite of the high dimensionality in the data, in spite of non-linearity in the data. It is quite possible that you are able to separate out the data distinctly. So because it's quite common that you cannot expect linearity in the data anytime. And also we have what are called as model ensembles. Now, when we talk about ensembles, it's not a single machine learning algorithm in place. It's quite possible that subjected to n things, be it with respect to the capability of the algorithm, or be it with respect to the quality of the data that is fed to the machine learning algorithms, it is quite possible that the algorithms do not give consistent results and results which can simply be acceptable in learning algorithms as weak algorithms. And of course, but there is a provision for you to have ensembles. That is, you will have a collection probably of machine learning algorithms which will strengthen a weak learner. And in fact, these are what are called as weak machine learners. So that is weak algorithms. So examples of machine learning algorithms which can be treated as ensembles are, you have AdaBoost, for example, which will try to boost the performance of the decision trees. Similarly, you have random forest, where it is possible for you to come up with the outcome, which is an aggregation of the outcome from several decision trees. So those are things with respect to the representation. Coming to evaluation, because at any point of time, it should be quite possible for you to evaluate your machine learning algorithm. So how would you be able to judge your particular
Excuse me, Miss. Okay. Good afternoon, Dr. Pooja. Okay.
Am I audible, madam? Fine. So similarly, when you're talking about margins, it could be regarding with respect to the separation of the objects using the support vector machines. Because as I said, support vector machines, in spite of the hindrance in the data in the form of non-linearity and being spread out in n dimensions, it is quite possible for you to identify a margin. And of course, these entropies, of course, these are measures which will actually start letting you know about the degree to which there is noise or degree to which there lies impurity in the data. It could be in the form of gain ratio, or it could be in the form of any index. Of course, all of these will try to evaluate the amount of impurity that is there in the data. And then comes optimization. So I said ML algorithms usually are there with respect to your representation, evaluation, and optimization. So with respect to optimization, you have three forms basically: combinatorial optimization, convex optimization, and then the constraint optimization. So with your combinatorial optimization, much of the tasks that you have here are much like your BSc, where you make a search for depth first search or your breadth first search, or probably if you have examples of traveling salesman problem. All of these are basically driven towards greedy search. Of course, though combinatorial optimization is not to a very larger extent used in the machine learning algorithms, it is still a preliminary form of optimization which could be used in the algorithms which work out at the raw stages. Going ahead, you have convex optimization. Now, all of these optimizations, we have worked, probably most of us would have come across many of the machine learning cost functions which work around gradient descent. And also, in fact, we have algorithms like stochastic gradient descent. And if most of where we do come across certain functions like RBF, radial basis functions, All of these will just look at the data being covered under a convex hull, because many a times it's quite possible that the data is not available in the form we desire. So it must be possible for you to guide the algorithm to adopt itself in spite of the inconsistencies being present in the data. And that is where you try to build a convex hull, which will probably draw all the data which is considered as desirable. Then in constraint optimization, we follow, of course, we do follow things as in convex optimization with a lot of constraints that are there on the outcome variables. So as in linear programming. So ML in practice, when we talk about, though we rely completely on algorithms, everywhere we keep saying algorithms and algorithms to a very large extent dependent on the data. But still what marks the successful outcome of ML in practice is about a lot of knowledge about the background domain, be it with respect to the health data or be it with respect to the sales data. So it is all about the studying the domain, the prior knowledge and the goal towards which you are working. And of course, since ML is a task, ML task does not initiate on its own until and unless you have a few of the preliminary tasks done in the prior phases, just like you have cleaning up of the data. For example, you set the data ready for processing. That is, you start pre-processing the data. Then you start to select the data without involving the data in its entirety. And then you start integrating the data. And of course, then you have the learning models. And finally, when you have the models, you must be able to interpret the results and basically evaluate the machine learning algorithms. As I said, with most of the evaluation techniques that we talked about. Then also we have consolidating and deploying the discovered knowledge. And the entire process, as we can see, is in a loop. So machine learning is not a one-time iteration and where you simply conclude that the algorithm is perfect for this task. So it does depend on the data to which you are exposing, how best it keeps getting tuned according to the data that you feed every time, what are the evaluation results that you end up with, and how do you want to have optimization in place. Would you be okay with convex optimization? Would you want to go to a stricter form of optimization where you have the adoption of constrained optimization? Now, coming to the applications of machine learning. So we did talk about machine learning so far. Talking about applications of machine learning. So you can see right from image recognition to automatic language translation, medical diagnosis, stock market trading, online fraud detection, virtual personal assistant, then spam filtering, self-driving cars, as we see, product recommendations, traffic prediction through speech recognition again. These are the broad applications that one can make out of machine learning. So let's highlight a few of the applications and the ongoing trends under those applications. So say, for example, you have image recognition. The best example is where you have automatic friend tagging suggestion. So say, for example, a friend has particularly tagged, or you might not have been tagged. So it is quite possible that the image recognition would have happened from your faces appearing on your profiles. And it is quite possible that automatic tagging of yourself is done when you happen to appear with your friends on the other pages. So that's a clear example for image recognition. So similarly, with respect to speech recognition, of course, you have text to speech, you have speech to text, you have, in fact, these oral chatbots these days, where you have the conversion from speech to text and text to speech, vice versa, as things have been happening. And of course, you have a lot of ML algorithms, such as natural language processing, which will underlie the entire concept of speech recognition. Coming to traffic prediction, let's say. So it is quite possible, especially when you're coming up with the self-driving cars. So it's quite possible that you have all these particular applications in place. But how has ML been in the front line to come up with traffic prediction? So it is quite possible that well in advance, it's able to capture the few pictures through a Google map, probably of all the vehicular traffic that has been coming across, and then probably keep a picture of that quick well in advance, and then come out also with the average time taken in the past history, so as to when that particular traffic would approach you, and then probably guide you through the different actions you can take out while driving. And also you happen to see product recommendations. So a huge number of entertainment companies, especially with respect to Netflix, Amazon, and all of these, especially which go on for the product recommendation. So say, for example, you have checked out for a few of the items, interested items on Amazon, you checked out on Flipkart, and on some other day, short by somewhere the weekend, you happen to go through, scroll your Facebook, and you see a lot of advertisements coming there. And you are just wondering as to how these advertisements did come up in this place. So this is because all these applications which have still been taken as third-party applications are permitted to be used on the application which you are using. So that is how you have product recommendations in place. And then coming to self-driving cars, as most of us are quite aware, you have Tesla. But how has it been motivated to be self-driving? So there are a lot of ML techniques in place, be it with respect to the computer vision, which have been trained and guided so that it gets to know the group of objects or the group of people. So it very much well in advance gets to know traffic that is coming in the opposite direction, or probably how it would probably have to take an action when it comes to cross people coming in the opposite direction. Okay, so that is how it's been tuned, trained, and it takes the best action accordingly. Coming to the email spam and malware filtering. So we have come across many situations. Say, for example, once or twice you start classifying few of your incoming mails as spam. And subsequently, automatically, you see that they get into the spam folders. So first few occurrences, first few times you probably would have input. Your suggestion is they shall get into the spam folder. And that would have dictated that the subsequent mails will have to get into the spam filtering. Okay. And of course, there are several constraints for you to mark what is spam. So currently we have provisions for content filtering, header filtering, then blacklist filtering, and of course the permission filters and the rule-based filters. So say, for example, from few of the authenticated entities, you do want to receive mails, but not of all categories. Probably you can apply your own rule-based filtering in that case. So how is this happening? Because you've been training and guiding the entire process, the learning is happening in place. And of course, you have virtual personal assistants, as with your Alexa. It's quite possible for you to dictate to the Alexa when you want to set up your time alarm, or probably when you want to play a piece of music at which point of time in the day, or probably when she has to automatically shut down. So all of these things do rely, for example, on the concept of speech recognition. Similarly, coming to online fraud detection, especially those of the machine learning algorithms which are in place with respect to web usage analytics. So there is the place where we have the consequence of online fraud detection. Fraudulent links, suspicious links are detected because the history of the transactions are monitored, from which links they have been, or probably from which unauthorized IDs particular trials have been done for the wrong things. So you have the identification of the fake accounts, fake IDs, and so on. Similarly, in stock market trading, especially this would be an example of regression, where you have the collection of continuous data over past several years, and this must be able to guide your entire regression task. So you have a huge number of machine learning algorithms, be it with respect to your cart, classification and regression tree. That is one which is especially used, especially when you want to look into continuous numerical values. Coming to medical diagnosis, of course, medical diagnosis has a lot of ML techniques in place. It could be with respect to the identification of the suspicious lumps in a piece of X-ray image that you have taken up, or might be a CT scan image that you have taken up. It is quite possible that you are able to very accurately predict the positioning and probably the size of this, and probably go ahead with the consequent prescriptive action for that. And of course, we have automatic language translation. Now, many a times it does happen that when you switch over geographically from one place to the other, you start getting these suggestions as per the language of that particular place. Or in spite of the language of that place, you start getting a translation to a language which is desirable to you. So how is all this made possible? It is there through NLP, which is there embedded as a concept of automatic language translation. So adding to the applications again, few of the real-time use cases that of AI, which everyone would have come across, is especially the AI-driven intelligent healthcare systems. Okay. So AI for wellness. What is this AI for wellness? So basically, it keeps dictating you at what times probably you need to consult your doctors. It keeps monitoring your vital parameters and sees that automatic messages, push-up notifications are sent to your doctors. In case of spikes, say for example, you see sudden spikes in some of the vital parameters, automatically it goes to your near and dear ones as well. So that is for wellness. And AI for mental illness is especially when you are talking about treating patients with depressions, you have mental illness. It is quite possible that we have behavioral modeling. So there comes the concept of behavioral model. So say for example, it has to be with your image recognition, well advanced techniques of computer vision, then probably be able to see that there are a few actions which are quite deviating from the normal behavioral modeling, and probably be able to infer few things about mental illness. And also these days, we know a lot of importance has been given to personalized treatment. And no more the treatment remains common for group cohorts of patients. So it goes according to personalization, where you're able to accelerate, fasten the entire process of recovery or the way the particular disease has an impact on the person's genome sequence. So that is especially biomarker discovery. Drugs, especially in tune with the genome specification of individuals, is biomarker discovery. And of course, coming to the educational sector, we have AI tutors. So with AI tutors, of course, we will no longer even require the physical teachers. It's quite possible that you have the chatbots as tutors and teachers working for it. Then also you have machine learning for educational data analytics and quality monitoring. It is quite possible that on your own you take your self-assessments, then probably you'll get a series of suggestions depending on the score or in the grade that you obtain. You better take up these set of courses so that you're best tuned for this particular domain. So that is, you will have a number of recommendations that are coming up as per the grade. But how is all this happening? Because probably, for example, you will have rule-based decisions. So if this is the grade and this is the desirable domain in which the student want to progress, probably these are the set of courses he wants to. So you will have a series of recommendations coming up. And therefore, this will surely match the tutors with students. And coming up with recommendation systems, as I said earlier, it's quite possible that we have product recommendations, if not the similar ones. It's quite possible that you are able to obtain cross-selling. This would promote cross-selling of products. You are searching for a particular group of products, but you fail to get the same category of products. But still, you are diverted to probably the other group of products, which can probably be substituting your desired products. So you have suitable product recommendation systems so that the customer is not left with the option of saying that I couldn't make up. So also we have location-based recommendations. Say for some time you had desire for a particular product on a particular lane in the city, and on some other day it happens that you happen to drive through that lane. And when you go through that lane, it is quite possible that you automatically get a push-up notification on your cell phone saying that you're almost close by to a sales shop where at one point of time you had desired a particular product. So how is this made possible? Because earlier when you had particularly searched for the product and the required sales location information was there, it will have been recorded. So that is a part of your history information, which comes into impact when you actually move through that particular lane. So that is, you get push-up notifications depending on the location. And also you have smart transportation systems. A good example of a smart transportation system is your pothole detection and mapping. And also with pothole detection and mapping, what happens is, this is to see that you don't come across undesired circumstances. So well in advance, while say for example, or you're on your traffic transit through a lane, it is quite possible all the upcoming potholes in that particular lanes, a picture of this appears on your GPS positioning system, on your application, and accordingly you are able to tune yourself to drive according on that lane. Might be you will probably apply the brakes as required, probably you make changes as per the lane through which you're moving. So this will surely make sure that you are able to overcome the undesirable results of any kind of accidents. And similarly, AI-based systems for lane changes. So with the GPS positioning system, with the real-time monitoring, that is the importance of machine learning. So everything goes in accordance with real-time monitoring. That is important here. So it's quite possible that it picks up the few undesirable things in a particular lane and then automatically starts guiding the driver of the vehicle to go in for alternate lanes, so that still he's able to end up with the target destination. So I think with this, I would like to conclude my session for today. And any clarifications, I would feel free to answer.
Okay. Maybe for our audience. Okay.
Hello?
First, we have question from
I'm not able to hear you, madam.
Yeah.
Yeah.
Hello.
Yes, yes.
Okay. Am I audible?
Yeah.
Am I audible, ma'am?
Yeah, you are audible.
Okay. Okay. Good morning, ma'am. Oh, okay. Good morning, ma'am. I would like to ask some questions. The first one is, between expert system and AI, are they both the same, ma'am?
Could I please see your question on the chat?
Okay, wait.
Kayaknya dosennya masih chat.
Kayaknya keluar ya? Keluar.
Bentar, jaringannya mungkin jelek. Tunggu sebentar ya, Kak.
Dari tadi sih sebetulnya. Oke.
Sana agak jelek jaringannya.
Mungkin pengaruh cuaca juga sih, Kak. Kan cuacanya lagi buruk.
Oh, bisa jadi gitu.
Aku copy dulu deh linknya.
Kak Raja semester berapa sekarang?
Aku semester 4.
Oh, udah lumayan lama. Jurusan apa sih, Kak?
Sistem informasi.
Sistem informasi.
Sistem
Beda.
informasi. Kakak? Kakak?
Bisnis baru semester 2.
Oh, baru masuk. Oh, beda 1 tahun berarti. Ini lagi UTS juga loh aku, Kak. Udah mau semester 5 malah. Lagi UTS ini. Udah mau semester 5. Nih, ya.
Tekomnya mana?
Aku di cabang Kendal. Yang cabang Kendal, Kendal kota.
Jauh.
Iya. Kakak mana?
Aku Majapahitnya.
Oh, yang pusat.
Pusat Semarang ya. lumayan lama ya ini
Kok
joinnya.
masuk nggak sih, Kak? Atau
Belum ini di list anggota masih belum ada.
enggak, maksudnya kalau emang maksudnya dosennya nggak bisa rejoin lagi gitu, apa udah dihubungin belum, Kak?
Bentar aku kontak orangnya WA bentar
Takutnya
ya.
kalau emang di sana udah
Ah,
benar-benar power cut gitu loh, nggak bisa itunya
bentar, aku
networknya.
WA dulu.
Mm-mm.
In connection. Oh, tadi siapa namanya ya?
Eh, Dokter Pooja kalau nggak salah. Iya,
Oh ya,
Dokter Pooja.
wait. She will off. Masih kendala internetnya sih Kak ini.
Oke, oke.
Nanti
Tapi
mencoba
maksudnya bakal rejoin atau cukup sesi
ya
ini,
ini
Kak?
confirm ke WA she will join again but
Oke.
very
Masih
slow.
ada network isu. Oke.
Benar,
Oh,
Kak.
oke. Oh. Kak, tapi itu kan harusnya ini biometrics ada kesalahan cetak di banner atau gimana ya?
Ya kayaknya kesalahan cetak di banner.
Kan. Soalnya tadi aku nanya sempat konfirmasi bukannya itu tuh Profesor Divya ya yang masalah apa tadi machine learning and
Iya,
its application. Nah, katanya enggak, itu malah justru biometrics gitu loh. Berarti
ya
kesalahan cetak ya.
thank you. Oke, masih berusaha menyelamatkan internetnya dia. Ada jalan. Ya baru first time ya kayak kejadian gitu.
Biasanya nggak pernah sih. Nggak tahu lah.
Kalau
Ya, namanya network, it is unpredictable.
tidak bisa diprediksi benar. Oh,
Gimana?
sudah join akhirnya.
Udah ya?
Mas Pak bisa dibantu co-host?
Oh,
Oke.
okay. Hello.
Yeah,
Hello, ma'am.
sorry, sorry.
Okay? Is it fine right now? It's fine.
Yeah, that's fine. Yeah, please.
Okay. Okay. Ma'am, between expert system and AI, are they both same?
Which one?
Expert system and AI.
Hello?
Hello, can you hear me? Am I audible?
Could you please repeat your question?
Do you know about expert system, ma'am?
Could you please,
Okay.
which one?
Do you know about expert system?
Yeah, sure.
Yeah.
Sure.
Between expert system and AI, are they both same or different?
Yeah, of course. When you come to expert systems, they are an incorporation of AI techniques. So as you might be quite aware, you have different classes of AI. Okay, you have narrow AI, you have specific AI. That goes to the extent to which the AI is really incorporated in that particular application. Okay, so when you have these broad AI, they would be exactly expert systems which you talk about.
Okay. So, ma'am,
They are the implementation of AI systems.
Okay, so it uses AI.
Yes, very much.
Okay, ma'am. Nowadays, deep learning is the most famous. Most people concerned about deep learning, but yeah, because it gives a highest accuracy as well. But then, why ML is still using if deep learning has a more highest accuracy? Because image classification can be done in DL also.
Yeah. But usually when you deploy this deep learning techniques, you probably get to make a choice of these kind of techniques if you're working on image data, where probably you can be having the visualization of the data in the form of several layers. Okay, so wherever you're probably working on numerical or synthetic data, which does not dictate you to deploy a deep learning technique. Okay, and probably one more thing is wherever you require human intervention, every now and then you want some subjective opinion to be given from the person who's running the algorithm, then deep learning is probably not preferable, because as I said, they are modeled as black box methods.
Okay, but someone ever said to me that machine learning is used for supervised learning method and deep learning is for unsupervised learning method.
That is why it is black box, because no one is guiding. When you say you have human intervention, it is much of supervised. You're coming in the place, okay, in between. You're guiding the process. So that is why many a times we do say ML might be to a very large extent applicable for supervised systems.
Okay. Ma'am, if someone want to dive in AI, especially in, I have one more, may I? Okay. If someone want to dive in,
please.
Please. Okay. If someone want to dive
could you please repeat?
Okay. Wait. Okay.
Someone
am I clear now, ma'am? Hello?
I'm not getting.
Hello?
It's not clear. Yes, tell me.
Am I audible right now?
Yeah, you are audible now.
Okay. If someone want to dive in AI, especially in deep learning, should we go through in ML first, or we can go straight up to DL?
Go straight up to AI.
DL, yeah. Which do you suggest?
That depends on the application. One cannot say deep learning is always AI. Okay, it goes according to the application perspective. Okay, say for example, you are deploying your DL, deep learning, basically for medical diagnosis, or which involves a lot of computer vision procedures to appropriately diagnose the place where probably your lesions are found, or depth to which the particular lesions are there in the particular human body space. So if that is your particular perspective, it's better you deploy deep learning. It's not that deep learning always for AI. One cannot conclude it like that.
Okay. So it depends on that person
perspective and the application theme that you're working towards.
Okay. Thank you for answering. Thank you.
Thank you so much.
Ms. Novita, I'm done. Thank you.
Okay, thank you for Miss.
Thank you, madam.
Rajas, I press no asking. Okay, I'll continue the closing knowledge with us. Hello. Thank you for joining this session, madam.
Thank you.
Yeah, thank you so much. Thank you for joining. And I hope we can meet again at other event. Thank you for
Sure.
all audience to join with us. Thank you so much, Dr.